Hello, welcome to my video. Today we're diving into definite integral of a function. So what we're going to be doing is we'll explore how to evaluate definite integrals using two methods, the fundamental theorem of calculus and the substitution method. Whether you're a student or simply passionate about math, this video is designed to make these concepts clear and approachable. Hi, and I am Edward Johan Quizon from 10 Rizal. So let's get right into it. In this video, you will learn how to illustrate and apply the substitution rule. Number 2, how to compute the definite integral of a function using substitution. Before we start, remember that integration and differentiation are inverse processes, a concept brought to life by the fundamental theorem of calculus. So first, let's recall the fundamental theorem of calculus. It tells us that if you have a continuous function, then its definite integral over an interval a and b can be computed using an antiderivative evaluated at the limits of integration. So in short, if f of x is an antiderivative of f of x, then it gives us this formula. Sometimes directly finding an antiderivative is challenging. So that's where the substitution method comes in handy. Essentially, substitution is the reverse of the chain rule, where an integral contains a function and its derivative. We can substitute part of this expression to simplify our work. So let's give this problem a try. So, our first problem, so example number 1. First, we'll use the fundamental theorem of calculus. So x minus 1 dx. So what we want to do first is use the binomial theorem to expand this. So what this turns into is x squared x plus 1 dx. Now for next step we have to evaluate the what's it called again? The indefinite integral. Sort of move the upper lower limit x squared minus 2x plus x. And after we evaluate the indefinite integral, now we integrate it term by term. So what's the integration of so for instance x squared dx plus integration of minus 2x dx and plus the integration of 1 dx. So equals x over 3 minus plus x. So and after that it's upper limit minus lower limit. So the definite integral is the antiderivative of the expression evaluated at the antiderivative of upper limit minus the lower limit of integration. So so basically it's upper limit minus lower limit again. So over 3 plus 2 minus 1 over 3 squared plus 1 equals, now we simplify for this, so 8 over 3 minus 4 plus 2 minus 1 over 3 minus 1 plus 1. Now this turns into, like we just, and now this one turns to 2 over 3 minus 1/3 equals 1/3. So that's our final answer. And after this, we'll be using the substitution method, and after that, we'll compare the both of them together. So let's use the substitution method. So we have a problem first. X. So let u equal x minus 1 and du equals dx. Both sides of the equation, u equals x minus 1. So u, which is du, and x minus 1, which is dx. we have to substitute u and du. So first, let's now substitute that first. Now, we substitute it. Now, okay, it's supposed to be sorry for the bad handwriting. Now, we substitute x minus 1 to u, so it becomes this. Now, since the definite integral is the antiderivative of the expression evaluated at the antiderivative of upper limit minus the lower limit of integration. So then the upper limit, since the upper limit is 2 and the lower limit is 1, so we have to do this. See, this is where the upper and lower limit go. Now we substitute upper limit minus lower limit. Now we simplify. So yeah, we simplify. Now this turns to 1 to the power of 3 over 3 minus this. Now this one turns to 0 to the power of 3 over 3. Now we simplify further. Now for the final one, it's 1 over 3. Yay! So as you can see, there is like no significant difference in terms of how easy it is when it comes to using the substitution method and the basic integration. However, as the function becomes like more difficult or more complex, the difference becomes more noticeable. Like if the problem is more complex, then substitution is way easier. So, what are the differences between the fundamental theorem of calculus and the substitution method? So, direct antiderivative versus change of variable. With the fundamental theorem of calculus method, you directly find an antiderivative f of x for f of x and then evaluate f of b minus f of a. With substitution, you first identify a component of the integrand that simplifies the expression, change the variable, and then the antiderivative in terms of u before converting back to x, or changing the limits directly. Next is when each is used. The FTC method is, or FTC, I like to call it FTC because it's shorter and faster than saying the fundamental theorem of calculus. The fundamental theorem of calculus is straightforward when the antiderivative is recognizable or easily obtainable. Substitution is useful for composite functions where the integrand includes a function and its derivative. This substitution transforms the integral into a simpler form. So next, for the final one, handling limits in definite integrals. In the FTC or fundamental theorem of calculus, you evaluate the antiderivative directly at the given endpoints. With substitution, you must either change the limits to match the new variable u, or substitute back into the original variable before applying the limits. These differences highlight that while both methods ultimately compute the same area around the curve, substitution can greatly simplify the process when the integrand structure suggests a natural change of variable. And that's all. In summary, I hope this video has given you an in-depth look on how to evaluate definite integrals using both the fundamental theorem of calculus and the substitution method. Okay, these methods are powerful tools in calculus that will serve you well as you progress in your studies. Thank you for watching. And bye bye. I think I won't make another video like this.